Is it good? Yeah. So girls, if you want to find the velocity and the acceleration sign at a certain point, so girls, to find the velocity, draw a tangent. That's something I taught you already yesterday. So if I draw a tangent at that point, girls, what's the sign of that line there? Negative. Negative, yep. So we know at P, the velocity is negative. That's easy. But the part that a lot of students get wrong, including myself, is what's the sign of the acceleration. And here's the notes. Girls, can you relate from the roller coaster video? When the slope is going down, so when you're here, doesn't it go really fast down, but after a certain point, it starts to slow down when you get closer to the bottom? Were you able to see that? So girls, that's actually the point. Girls, it increases in speed in the first half, but it decreases in speed in the second half. That's the keynote. So in other words, it increases in speed, but it slows down in the second half. Okay? So at point P, it's obviously what? Slowing down, because it's after the halfway point. So when something is slowing down or decreasing in speed, this is the important note. You take the opposite sign of the velocity. Okay? So my velocity sign is negative, so that means the acceleration is positive. Okay? And the reason why you take the opposite sign is this. Girls, when the velocity is negative, let's have a look at this moving man, right? Girls, when your velocity is negative, that just means you're moving to the left. So let's say my velocity is -3, right? And my acceleration though, let's say it's +2, yeah? So this is what it means. Let me play it. So you're moving to the left and then slowing down, and it's actually forcing it to go back to the right. So when the velocity sign and the acceleration signs are different, it means it's slowing down. Whereas if the velocity sign and the acceleration sign was the same, that means you're going fast in that direction, faster and faster. Let's try it out. So if I put in the velocity -3, put this back to 0, and my acceleration was also -2, both minus, that means you're going that direction faster and faster and faster, faster. Okay? So that's why when something's slowing down, you take the opposite sign of the velocity. Does that make sense? Yeah. Now, so let's do another example. So for example, let's say I have another point here. Let's say Q. So at this point, the velocity looking at the tangent, that's increasing. So the velocity is positive. But at this point, is it slowing down or increasing in speed? Slowing down. Yeah, as you saw from the roller coaster, in the beginning, it needs to increase in speed. It needs to go faster and faster to get off the bottom. But as we approach the peak or the vertex, it starts to slow down. So therefore, the acceleration would be, because it's slowing down? Negative. You take the opposite sign of the velocity. Does that make sense? Okay. So girls, that's how you do it from XT graph. Now, sometimes what they'll do is they'll ask you the same thing from V and T graph. So girls, let's transform the displacement graph to velocity. How do we do that? As usual, let's mark all the gradient signs over the graph. So all of this is positive. Up until here is 0. Here is negative, 0, and then positive. So positive, 0, negative, 0. All right, so remember, these are the points that you want to mark on your new graph for velocity. Remember that? So that means it has to go through 2 and 4 on the velocity graph. Up until here, they're all positive y values. So am I going to draw a graph above or below it? Above it. And now from 0, you see this part of the graph is negative, so under. But then it's going to go back to 0 and positive up. So it's going to look like this. Does that make sense? Now, see this point P? Where do you think that is about in here? It's between... This is a velocity graph. The point P is there when we transform here to there. Now, girls, P is below the x-axis or the time axis. That means the velocity is negative. Okay, that's how you read it. If it's below the x-axis, it's negative velocity numbers, which means the velocity is negative. Does that make sense? Now, for the acceleration though, how do you get acceleration from velocity equation? What did we do yesterday? You differentiate velocity to get the acceleration. That means graphically, you want to get the tangent at the point P to get the sign of the acceleration, because the tangent is the differentiation of velocity. So what's that gradient sign? Is that positive or negative? Positive. Yeah? And that confirms what I had in my previous graph as well. Yeah? So that's how you read the sign of the velocity and acceleration from these two graphs. Okay? Whereas yesterday, the main lesson was, it's from the same graph, when is it at rest? That's when the velocity is 0. That's when the tangent is 0. So these 2 points. So in this case, the answer would be t equals to 1 and 2. Okay? And it's at the origin when it hits the x-axis. In this case, it's just 0. Girls, another common HSC question which you girls will also need to know for the booklet. Girls, from this graph, x versus t graph, the maximum displacement is obviously 10 meters, right? That's the highest point. So that's the maximum displacement. Some of you girls were asking me, what does maximum displacement mean? That's what it means, the highest point on the graph. Yeah? And when does that occur if you go down? Yeah, so t equals to 2, right? That's pretty easy and they will never ask you that. What they usually ask you is find out what the maximum displacement is from the velocity graph, all right? And they usually give you the velocity graph, but in our situation for demonstration purposes, let's transform this into velocity graph. So let's do the same thing as what we did before. Let's go to get the gradient signs. So what's that? Positive, 0, negative, right? And it has to go through there. Yep, so 1, 2, 3, 4, it has to go through to positive, 0 down to negative. So that means it's just a straight line that goes this way, yeah? So to get the maximum velocity, maximum displacement, it occurs at the t-intercept or the x-intercept. So in this case, t equals to 2. Okay? And as you can see, it's the same answer. Yeah? Let's change this into velocity graph and see what happens again. So let me just get the gradient signs quickly. Negative, 0, positive. So it has to go through 2 and 4 this time. Positive, down to negative, and then, it's going to be this. But it stops at a certain point. Yeah, because it stops at a certain point. Girls, if this was the velocity graph, and they asked you for the maximum displacement, notice how this time though, we got 2 x-intercepts or 2 t-intercepts. The question is, which one do you choose? Because here we only had 1 and that was straightforward. But here you've got the option of t equals to 2 and 4. And that's the question. The answer is, obviously, if we look at it from here, it's obviously 2, right? So the answer is 2, but why is it 2 and not 4? From here, what you do, girls, these are all positive velocity, isn't it? Yeah? But as soon as we go down here, we have negative velocity, which leads to that. So girls, that's not the answer because if I choose that one, that includes all the negative opposite direction. We want to stop and get the one where it's only counts for positive velocity. Does that make sense? So that's how you read it. One more thing, girls, another question. Let's say this was a graph. Girls, this is another typical question. Not typical, it does come out there. How many times does, how many changes of directions are there? So let's go back to the moving man. If the velocity is negative, you're going to the left, yeah? If the velocity is positive, you're going to the right, yeah? So all of this section here, these are all positive velocity, yeah? That's one direction. Yep. How about here? These are all below, so these are negative velocity, isn't it? How about here? So how many times does it change direction? 3 times. That's how you read it. Twice. Sorry, 3. Yeah, it starts off as positive, but then it changes here and then it changes here again. Thank you. Changes direction twice. Yeah, does that make sense? You don't count this one. You're already starting from positive side. But then you're changing it to negative side here. And then from this negative side, you're going back to positive side. Yes, it changes twice.
So is it technically the amount of time we go through the x-axis?
Yeah, basically, yeah, that's right. No, then there would just be once. If the graph ended here, just like that?
learning that.